Friends, my name is Kaustubh Panse from 11th standard. In this video, we will study about electrochemical cell and electrode potential. In this video, we will study about electrochemical cell, their definition and components and working, salt bridge, electrode potential, their types, electrochemical series and redox couple. Let's start from electrochemical cell. Electrochemical cell is basically a cell which is capable of converting, rather actually converts, chemical energy into electrical energy. In this image you can see that it consists of two containers containing electrolytes with electrodes dipped into them, a voltmeter connected to both the electrodes, and salt bridge. Now we will study about some concepts like electrolyte electrodes. Electrolyte is a solution having the capacity of conducting electric current due to the presence of free ions in them, which are a result of dissociation. Electrodes are the site of reaction in this entire cell. These are basically two dots made up of conductors and are often called as anode and cathode with respect to each other. In case of adjoining cell, the copper rod is acting as cathode while the zinc rod is acting as anode. In earlier standard, we have studied about anode and cathode. Voltmeter is the device which is used to measure the potential difference across two points in a circuit. Salt bridge is actually a U-shaped tube containing a mixture of agar and potassium salts. It links the two halves, oxidation and reduction of the cell, and acts to maintain the neutrality as well as progresses the reaction. Now we will study about working of electrochemical cell. In the given cell, zinc rod dipped into ZnSO4 solution and acting as anode starts losing electrons, that is, undergoes oxidation. Thus, anode develops negative charge. Reaction at anode is Zn gives Zn2 plus 2 electrons. In the beaker containing the copper rod, CuSO4 electrolyte is present in the form of Cu2 and SO4 ions. Thus, when zinc anode starts releasing electrons, Cu2 ions take up those released electrons to form solid copper. This copper, after formation, gets deposits on the electrode. As it is a gain of electrons, the process is reduction. Thus, copper rod is the cathode in the given cell and has a positive charge developed on it. The reaction at cathode is Cu2 plus 2 electrons gives Cu solid. In this entire process, the Zn2 formed after the reaction gets dissolved in the solvent while Cu2 is actually being obtained as a byproduct. Anode by the end of the reaction gets thinner and thinner while cathode grows in size owing to the deposition of copper. The reaction of this process is given here at the left. Zn plus CuSO4 gives ZnSO4 aqueous plus Cu solid. In this reaction, ZnSO4 is oxidized and Cu is reduced. Now we will study about salt bridge briefly. Salt bridge, as stated earlier, is a U-shaped tube filled with either agar or gelatin mixed with mostly potassium salts like KCl, KClO4 or NH4NO3 in them. These salts are often present in dissociated forms. If not, they do dissociate themselves when it's required. The main function of this salt bridge is to maintain the internal circuit. In other words, it works to maintain the solution's neutrality. The reason behind using potassium salts is as simple as it can get. Potassium is most reactive of all metals. Thus, it can never react with metals less reactive than itself. This behavior of potassium is what helps us to maintain the balance in the reaction. The salt bridge and its contents remain inert throughout the entire course of reaction, not participating and not leading to formation of new products. As a result of the formation of Zn2 plus and SO4 2 minus ions, a potential difference is generated across the electrolytes. Thus, electrons start moving from the negative terminal to the positive terminal, and this is called as liquid junction potential or LJP. Along with doing the job of maintaining neutrality by avoiding the development of LJP, salt bridge also works to initiate as well as progress the entire reaction. Thus, it's a rather important component of the entire setup of electrochemical cell. Electrode potential. Standard electrode potential. Potential difference developed between the electrode and the electrolyte is termed as standard electrode potential or SEP. For example, in the previous example, there was a potential difference between zinc rod and zinc sulfate solution, or copper rod and copper sulfate solution. There are two types of SEP: standard oxidation potential, that is SOP, and standard reduction potential, that is SRP. Standard oxidation potential (SOP). Potential difference between the electrode and the electrolyte where oxidation takes place. Second, standard reduction potential, which is also known as SRP. Potential difference across electrode and electrolyte where reduction takes place. Third, standard hydrogen potential SHE. This is the potential which is used as a reference to calculate the electrolyte potential of other electrodes. Its value is 0.00 volt. Electrochemical series. Electrochemical series is the arrangement of the elements in an increasing or decreasing order of electrode potential. According to this series, the more negative the value of SRP, the better is the element as reducing agent or anode. The more the value of SRP is positive or less negative, the better is the element as oxidizing agent or cathode. Elements with least SRP value or higher negative value are highly reactive, while elements with low SRP value or more positive value are less reactive with respect to the former. Cations with high SRP values discharge fast, while anions with more negative SRP values discharge slow. Table of electrochemical series is given here. Now we will discuss about redox couple, the pair of an oxidizing and reducing agent that are involved in a particular reaction is called as a redox couple. In order to identify which is anode and cathode in the given pair, just check their SRP values. The one with more negative value will act as an anode, while the one with more positive value will act as cathode. For example, MnO4 minus has E0, we read as E0, is equal to 1.51 volt, while Cr2O7 2 minus has E0 is equal to 1.33 volt. Thus, Cr2O7 2 minus will act as anode, while MnO4 minus will act as cathode. Now second example. Cl2 with E0 is equal to 1.36 volt and Br2 with E0 is equal to 1.9 volt. Thus, Br2 will act as anode while Cl2 will act as cathode. Now we will learn calculation of cell potential. In order to calculate the electrode potential of cell, we need to have balanced chemical reaction. Post balancing, using the following formula, which is we can easily determine the potential of cell. Potential of cell is equal to SRP of cathode minus SRP of anode. For example, to calculate the cell potential with electrodes Fe and I in the following reaction, we will first balance them. If they are unbalanced, 2Fe3 plus 2E minus gives 2Fe2 plus. 2I minus gives I2 plus 2E minus. Here SRP of Fe is 0.77 volt and SRP of I is 0.54 volt. Therefore, cell potential is equal to SRP of cathode minus SRP of anode is equal to 0.77 into 2 minus 0.54 into 1. Hence, after subtraction, cell potential we get is 1 volt. If cell potential is positive, then the reaction is spontaneous, while if it's negative, then the reaction is non-spontaneous. Hope you understood all this explanation about electrochemical cell and electrode potential. Thank you.